extra passengers, what will happen? You see, you will first reach a limit of the TIT. So you will see the EGT and the torque increasing, both of them. Which one will reach the red line first? This one. And the torque will not have reached the limit. If you are the same thing, starting from the same place with the same people in the winter, you are on this side of the flat rating temperature. What will you reach? The EGT and the torque are raising, raising, raising. Which one will reach first its limit? This is the torque. So you see, same helicopter, same engine, same weight, same people on board, same pilot, everything. What is changed? Same place. You are taking from the same altitude. What has changed? The temperature, OAT, compared to the flat rating. So if you are on this side in the summer, first you will reach a limit of EGT. If you are on this side in the winter, you will reach the limit of the torque. And this is like this. It is like this in reality. This is what you can see. And this is explained by this problem of flat rating temperature. In fact, the problem is much more complex than that. I will explain you that later on, because this is a 3D problem. You have also the importance of the altitude. I mean the pressure altitude, PA. The pressure altitude, PA. So not Pascal, yes, in Pascal, but the pressure altitude, I mean. And the problem is a combination of this and that, because when you decrease the altitude, the power is also increasing. And so the power is increasing due to two things, OAT and the altitude. And if you are going to a lower altitude with a lower temperature, these are two reasons to go over the mechanical limit. And so the problem is a very complex problem, but that must be implemented. There is a mechanical limit, and you cannot go over. And this is a limit that you can easily measure and control thanks to a torque meter that you have on board of your system. And with a second limit that is due to the TIT, but that we cannot measure, and that we can measure maybe with the EGT. And this flat rating problem is a general problem that we can first explain in the turbo shaft. It's very clear in the turbo shaft. We see what is there making the limit. This is the shaft and the gearbox. In aircraft engines, it will be a bit different, and we will come back to that when we are discussing the second part of the course with the working lines and the working points, where we will come back to this situation. Of course, in order to be complete, the flat rating temperature is, when you indicate it here, a function of PA. It's function of the third parameter. But I will not extend myself on that today, but the flat rating temperature is the limit between mechanical domain and thermal domain, the limits for the turbo shaft, and is changing with the pressure altitude of the engine. Thank you.